Okay, so this next section, section 3, is explaining the regulation of male and female reproductive systems in terms of hormone secretion. So we're going to talk a lot about hormones in here. We're going to take this with the male reproductive system first, and we'll call that video 3A, and then we're going to do a separate video on the female reproductive system. We'll call that 3B. Okay, so let's go ahead, and this one's going to go over the male reproductive system. So this is the one we're going to go over first. Okay, sorry about that. So again, just a picture showing you the structures that we're going to be talking about. So if you're not sure, go back and take a look at lab. There are some video links along the way. This one right here that Armando has, there's a handout in your packet that goes along with that. I strongly encourage y'all to take a look at that. I'm not sure this John Wiley tutorial even works anymore, to be perfectly honest. I'm betting it does not. I'm just going to click on it just to make sure. Because I think at one time those were, yeah, it doesn't look like it's going to work. Sorry that link is in there. But yes, it doesn't work. I think those were like shockwave kind of things, and it's been a minute, and I've just never removed it from the PowerPoint here. Okay, so now let's take a look at regulation of the male reproductive system and the hormone pathways. Now, y'all should already be fairly familiar with this. She should not be new information whatsoever, but let's review. So you've got your male HPG axis, so that stands for hypothalamus, pituitary gland, and gonads is what that stands for. It's telling you the basically flow of hormones starting with the hypothalamus all the way to the testes. So the hypothalamus, as you know, secretes gonadotropin releasing hormone. Keep in mind, any of those releasing or inhibiting terms means it's coming from the hypothalamus. That plus sign means it's going to actually release that as opposed to inhibit. Okay, that's going to target the anterior pituitary gland. So not just the pituitary, but the anterior pituitary gland. And when GnRH shows up, it is going to cause the secretion of luteinizing hormone and follicle stimulating hormone from the anterior pituitary gland. These two hormones, luteinizing hormone and follicle stimulating hormone, again, will travel just like all these other ones did through the bloodstream until they reach the gonads. In this case, we're talking male, so it will be the testes. This will cause the secretion of testosterone, another hormone. So that is the flow of information, hormones from beginning to end, basically. Now, the testosterone is going to have some negative feedback involved, so when it shows up, it will prevent the secretion of LH and FSH from the anterior pituitary, and the testosterone will also have negative feedback going back to the hypothalamus, preventing the secretion of GnRH. So that's what those negatives mean over there. That is showing you the negative feedback mechanism. So this just doesn't keep producing and producing and producing. When testosterone is present, it's like, hey, we got what we wanted. We made testosterone, so quit telling us to make more. We've got what we need. So again, should be review. Now, this is snippets from that video just so you can kind of see what's going on here a little bit. We mentioned this previously in the female reproductive system, but I did want to let you know that in that interstitial space of the testes, keep in mind this is the seminiferous tubule, but in that interstitial space, there are capillaries. And this is where luteinizing hormone and follicle stimulating hormone are going to come from. So they're entering this interstitial space by way of those capillaries that came, if we back up a minute, from the anterior pituitary. It's going to release LH and FSH into the bloodstream, and then that is where they will get offloaded. They're going to travel through the bloodstream until they get to that interstitial space in the testes. I said within the interstitial space of the seminiferous tubule. Okay, seminiferous tubule is not part of the interstitial space. You got interstitial space and seminiferous tubule of the testes. Two separate areas. The capillaries are going to come in through the space, not the tubule. And then that's where luteinizing hormone and follicle stimulating hormone will be dropped. Now, you have got the target. Where are these going? What's luteinizing hormone targeting? What's follicle stimulating hormone targeting? Luteinizing hormone is going to target the Leydig cells. Keep in mind, these are interstitial cells. Those are cells not within the seminiferous tubule. And that LH, luteinizing hormone, is going to target those. and cause them to secrete testosterone. Now, testosterone is an androgen, and androgen is an umbrella term that includes a couple of different things, but the one that we're going to be talking about, the primary androgen that we're going to be talking about, is testosterone. Not even going to mention any of the other ones. So, Leydig cells, interstitial cells located within the interstitial space, and luteinizing hormone will target those to make testosterone. Okay, the Sertoli cells, remember those are located within the seminiferous tubule. There's that Sertoli cell right there. Spermatogonia cells are also located, those sperm stem cells are also located within that seminiferous tubule. And you can see right here the way that's organized is this is going to be that outer layer, and then that material, you know, those sperm as they mature are going to move towards the lumen. So just showing you again, we talked about that previously, the structure of the seminiferous tubule, and that's where those are. Now, testosterone. It stimulates the Sertoli cells within the seminiferous tubule. So if we back up a minute, these Sertoli cells right here, how do they know when they're supposed to do their job? Well, testosterone shows up. Remember, we have got luteinizing hormone that is going to tell these Leydig cells, these interstitial cells, to make testosterone, and that testosterone is going to go to the nurse cell or the Sertoli cell, and it's going to stimulate them. So that's how they know they're supposed to start their job. So what are the other effects besides testosterone telling the Sertoli cells, hey, you need to start doing your job? We'll talk about that in a second. What other effects does testosterone have? Well, you've got your peripheral effects, which aren't directly involved in sperm production. It's going to maintain the sex drive of the male, stimulate bone and muscle growth, maintain male secondary characteristics, which is going to be beard and deep voice, and maintain those accessory glands and organs, which we mentioned previously, for example, the prostate gland. Okay, so mechanisms of negative feedback of testosterone. We already mentioned this previously 2 slides ago, but when testosterone levels are high, when you have testosterone available in the bloodstream, that will then inhibit the anterior pituitary from secreting LH and FSH. So even though gonadotropin releasing hormone might be coming through, that testosterone presence is going to inhibit luteinizing hormone and follicle stimulating hormone from being secreted. Now, it's also going to inhibit gonadotropin releasing hormone from going from the hypothalamus, telling the anterior pituitary to secrete this. So you kind of have 2 mechanisms here involved, 2 negative feedback loops preventing luteinizing hormone and follicle stimulating hormone from being secreted. Now, let's talk about those nurse cells, those Sertoli cells. So we know that testosterone is going to target those cells. Follicle stimulating hormone also is going to target the Sertoli cells. So you've got 2 hormones coming in talking to the Sertoli cells. You have your testosterone. Let me just get a different little thing here. You have testosterone and you have FSH. Both of them are talking to the Sertoli cells. So you've got to have both. If only one of them shows up, nothing's going to happen. You got to have both. So the presence of that follicle stimulating hormone and testosterone stimulate the cells to secrete this substance called ABP, androgen binding protein. And it does exactly what it says it does. It binds an androgen. Well, what androgen are we talking about? We're talking about testosterone. So when the Sertoli cells recognize FSH and testosterone are both present, it will then secrete androgen binding protein, which binds testosterone. So it's, I know you got testosterone acting on the Sertoli cells, and then you have ABP binding it. So I know it's kind of roundabout. The androgen binding protein binds the testosterone, which causes the spermatozoa to undergo sperm production. So it starts that spermatozoa, which is a sperm cell, to undergo those 2 processes, spermatocytogenesis and spermiogenesis. Okay, spermatogenesis, same thing. So it causes that spermatozoa to start, hey, you're a stem cell, start doing your job, start making, undergo mitosis, and then I need you to undergo meiosis 1 and meiosis 2. Now that spermatozoa, as it matures, will end up in the lumen of the seminiferous tubule. Remember, that's where it's heading to. Then it will enter the it's not really spermatozoa. It is sperm at this point. But it will enter the rete testi and then the epididymis, right? The head, the body, and the tail, which will then enter the vas deferens. So the hypothalamic pituitary gonadal axis, again, for the male. You've got your hypothalamus, which is secreting that gonadotropin releasing hormone. It will then cause that pituitary gland, anterior pituitary, to secrete FSH and LH. Luteinizing hormone is going to act on the Leydig cells, where FSH is going to act on the Sertoli cells. Now, the Leydig cells are going to secrete testosterone. So when you have testosterone and FSH, that will cause the Sertoli cells to initiate spermatogenesis. So it's going to tell those spermatogonium cells, hey, stem cell, you need to start doing your job there. And remember, those Sertoli cells are going to do that by secreting that androgen binding protein. Now, the presence of testosterone, now that testosterone has been made, while it's going to stimulate spermatogenesis, it will then inhibit the anterior pituitary from secreting FSH and LH, and it will inhibit the hypothalamus from secreting gonadotropin-releasing hormone. Now, we do have this other hormone that is coming into play, which is called inhibin. So not only do the Sertoli cells secrete androgen-binding protein, they also secrete inhibin. So again, it's kind of, you're doing the same thing twice here. You've got testosterone and now inhibin targeting the anterior pituitary, telling it to stop secreting FSH and LH. So testosterone, again, is an androgen. Androgen is a big umbrella term. The specific androgen we're talking about is testosterone, and it's a steroid hormone. It's produced by the Leydig cells, also known as interstitial cells, which is located between the seminiferous tubules in the testes. So it's in that interstitial space, just showing you again where that, let me get those. Just looking for the seminiferous tubule. There we go. Seminiferous tubule right there. So we're talking about the space between that interstitial space. The space between the tubules. Okay, testosterone in male embryos is secreted by Leydig cells by the 7th week of development, with peak concentrations reaching the 2nd trimester. So, in male embryos, testosterone actually gets secreted pretty darn early, 7th week. This early release results in the anatomical differentiation of the male sexual organs. So it's kind of like letting the embryo know, okay, we're going to go this route rather than this route, and that's because of the presence of testosterone. In childhood, testosterone concentrations are going to be low. Once puberty is reached, that is going to increase those testosterone levels, which will then initiate spermatocytogenesis and then spermiogenesis. Functions of testosterone, again, continued presence is necessary to keep the male reproductive system working. As a mature male, Leydig cells are going to produce about 6 to 7 milligrams of testosterone each day. Maintaining these concentrations results in spermatogenesis. So with a male, they're able to make sperm throughout the duration of their life, provided those levels stay high enough. Low levels can lead to infertility. Okay, so now we're going to take a look at 3B, but that will be in the next video. So we're going to do that in a separate video. So that concludes 3A, chapter 27 for the male reproductive system and the hormones.